Okay, so we do the exponential distribution. Exponential distribution. So for exponential distribution, then it's also a continuous special distribution with parameter lambda, and it has the PDF f of x is equal to, so this one goes with its parameter, so f of x with the parameter lambda is equal to lambda e to the power negative lambda x, provided x is greater than 0. So first thing is to verify that it is indeed a probability distribution function. That is, Ox of this function should give us 1. So let's do the verification. So say from 0 to infinite, lambda e negative lambda x dx. So we can take the lambda outside so that we have this dx, and this is just the inside, 1 over negative lambda e to the power negative lambda x from 0 to infinity. So exponential to the power negative infinity is 0. So we have lambda 0 minus 1 minus lambda, and e to the power 0 is 1. So we just have this, which is lambda 1 over lambda, which is 1. So we have verified that it is indeed a probability density function. So you need to know this process because you can be asked to do this. Then we now go for the definition. So we are trying to look for the expectation, for the variance, and for the MGF. So we are saying if x follows an exponential distribution, then 1, the expectation is going to be 1 over lambda. 2, the variance is going to be 1 over lambda squared. And 3, the MGF is going to be lambda over lambda minus t, provided t is less than lambda. So there you could also pick the modulus of t. So let's go and check a proof. So proof or verifications. 1, the expectation, by definition, in this case we run from 0 to infinity of x, f of x dx, which is from 0 to infinity of lambda e to the power negative lambda x multiplied by x at dx. So the lambda can come out, but the x here doesn't come out. So integrating this, we use by parts. So you let u to be x, and let your du then is going to be just dx, and then your dv is going to be e to the power negative lambda x dx, so that your v, the integral of that, becomes negative 1 over lambda e to the power negative lambda x. And so we are saying a lambda x from 0 to infinity of this dx is equal to uv, which is negative x, over lambda e negative lambda x minus v du. So this is going to be plus, so I'll leave 1 over lambda outside and take this inside, dx from 0 to infinity, so that this one should be rated from 0 to infinity. So for this one, we'll be taking the limit, but when we take infinity there, we have 0, and when you take 0 again, we have 0. So everything becomes 0. So we just have 0 plus 1 over lambda 0 to infinity e negative lambda x dx. So when you integrate the inside, it becomes 1 over lambda, and then we have negative 1 over lambda e to the power negative lambda x from 0 to infinity. So when we substitute again, what are we getting? So when you take x, when you take infinity, we have 0, then minus. So we have this, then minus. So it's going to be this, which is 1 over lambda squared. So what's happening? The expectation, so this is supposed to be variance. Okay, so it's fine. So we left out this lambda outside here. So bring it back. And so also it's supposed to be here. So even here, so that we have it here. And so we get 1 over lambda as required. Okay, so let's go to the variance. So variance, for variance, we know that we need to get this minus this squared, which is equal to, so our target now is to look for this, which is 0 to infinity x squared lambda e negative lambda x dx. So this is going to be lambda outside x squared e negative lambda x dx. So again, we use by parts, so that du is 2x dx, dv is e negative lambda x, so the x is in the numerator, so the power also dx, so that our v is negative 1 over lambda e negative lambda x. So what we have as our first thing is negative x squared over lambda e to the power negative lambda x plus 2 over lambda. So remember that we have this lambda outside. So 2 over lambda, the integral of e to the power, so there is x, then negative lambda x from 0 to infinity. This one, 0 to infinity, and then dx. So for the first part again, when we take infinity, we get 0. When we take 0, we get 0. So it's just 0. This is just the same as 2. Now this lambda and that lambda, so we just have 2, 0 to infinity, x e negative lambda x dx. But this is what we integrated in the other question. and we got 1 over lambda. So we have 2 over lambda, and so we bring in the other part. So the variance now is going to be 2 over lambda minus 1 over lambda squared. Lambda squared, which is expectation. So the common denominator is this, and so we have 2. So lambda into lambda squared, we get lambda. So we have 2 lambda minus lambda squared in lambda squared, we're going to get 1. What do we have? That is infinite there, 0. And then 2 over lambda x e, then this lambda down takes away that lambda. So we have 2, 0 to infinity x e negative lambda x dx. Yes. So even if we integrate this one, we'll get the very thing that we got in the other question, except this one will be multiplying by 2. Is it not the same? It is x. Oh, okay, I see. So it's not the same. Okay. So it's not the same. So we need to integrate this part. Again, using product rule. So we let u to be x, and then du is going to be dx. Then dv is going to be e to the power that dx, so that v negative 1 over lambda e negative lambda x. So this time around we don't have a lambda. In the other one we had a lambda. So what we have now is 2 negative x over lambda e power negative x lambda minus, so that we have plus the integral of 1 over lambda e to the power negative lambda x dx. So from 0 to infinity. So this is lambda. Okay. So these, they run from 0 to infinity. And again, when you look at it, when we take infinite, we get 0. When we take 0, we get infinite. So we have 0 there. So we just remain with 2 over lambda, the integral from 0 to infinite, e negative lambda x dx. And this is the same as 2 over lambda squared, because when we integrate, we are going to have 2 over lambda outside and negative 1 over lambda inside, e to that, then 0 to infinite. When we take infinite, we get 0. When we take 0, we get 1. So we're just going to get 2 over that, negative 1 over lambda, which gives us 2 over lambda squared. So what do we have? We have now the variance as 2 over lambda squared minus 1 over lambda squared, which is expectation. So we have lambda squared down. So then we get 2 minus 1, which is 1 over lambda squared. Okay, as required. Okay, so we move on to the MGF. The third one, the moment-generating function, is going to be the integral from 0, or first we put its definition, which is this. so which is the integral from 0 to infinity, etx multiplied by lambda e negative lambda x dx. So the lambda comes out, and then these powers will add, and they'll add in this manner. The x go outside, but because of the infinite, we'll write this as e negative lambda minus t x dx. Then we integrate, so that will come out as negative lambda minus t, and then e negative lambda minus t x 0 to infinity. So that we get negative lambda over lambda minus t. When we take infinity, they are going to get 0, minus when we take 0, they are going to get 1, so that everything becomes positive lambda over lambda minus t, provided t is less than lambda. And is it what you're looking for? Yes, that's what you're looking for. So I have verified all the three. So now we can look at an example. Example, if you let x be an exponential, so let x be an exponential random variable with mean 6, find a x is greater than 4, b the probability x is greater than 6, given that x was greater than 2. So the solution, first thing we need to bring the function lambda e negative lambda t, provided negative lambda x, provided x is greater than 0. Okay, then we have been given that the mean is 6, and we know that the mean is 1 over lambda. So this is implying that 1 over lambda is 6. So lambda is 1 over 6. Of course, we need lambda. So our function now is 1 over 6 e to the power negative 1 over 6x. That is our function for now. So when we are looking at a, the probability x is greater than 4, what do we mean? We mean integrating from where? From 4 to infinity. Integrating 1 over 6 e to the power negative 1 over 6 x dx. So that's going to be 1 over 6 outside, and then we integrate this e that x dx, and this is just 1 over x. Then we'll drop it down, so it's going to be 1 over negative 1 over 6 e to the power negative 1 over 6x from 4 to infinity. So this 6 will take away that 6. So we're going to have negative e negative 1 over 6x from 4 to infinity. So when you take infinity, we get 0, minus minus, so it's going to be plus 4 e to the power of negative 4 over 6. So we have e to the power negative 4 over 6 as the probability for x greater than 4. like that. Then for B, the probability x is greater than 6, given that x is greater than 2. So this is just the intersection because it's a conditional. So you get the probability x is greater than 6, and then you intersect the probability that x is greater than 2 and divide by the probability that x is greater than 2. That's from the, so you're intersecting those top intervals there, x greater than 6, intersection x greater than 6, 2. So you understand that if you're in a number line, this is 2, that is 6. Greater than 2, greater than 6, you're starting from here going this side. Greater than 2 from here going this side. So the intersection will be this part. So that we just get the probability x greater than 6 over the probability x greater than 2. So we need to find all this. So I haven't found any. So the probability x greater than 6 is just from 6 to infinity, 1 over 6 e negative 1 over 6x dx, and this is 1 over 6 negative 1 over 6 e that x from 6 to infinity. And so this goes, so again we're going to, after integrating, we'll get 0 minus minus, which is just plus, e 6 over 6 negative, which is just e negative 1. Then you come back and do x greater than 2. That is from 2 to infinity, 1 over 6 e negative 1 over 6x dx. So this is again 1 over 6 neg 1 over 1 over 6 e neg 1 over 6x from 2 to infinity. Again, this and that goes, so we have 0 minus minus, so it becomes plus e negative 2 over 6, which is just e negative 1 over 3. So what we are having now is the probability x is greater than 6, given x is greater than 2, is going to be e negative 1 over e negative 1 over 3. So what is this? This is the same as, if you want, you can say this is the same as e okay, this is the same as e negative 1 multiplied by e positive 1 over 3. So that if you want, you can say e 1 over 3 minus 1. So that we get e negative 2 over 3. So this should be the solution. E negative 2 over 3. And as equal, the exponential distribution is a memoryless has got a memoryless property, so it does not keep time. An example is the probability of waiting for more than 4 minutes is the same as that of waiting for more than 4 additional minutes, given that you have already waited for more than 2 minutes. Is it? Okay, yeah. Because here you could simplify this as e. We divide by 2, we get negative 2 over 3. So the probability of waiting for more than 4 minutes is the same as waiting for more than 6 minutes, provided you waited for more than 2 minutes. So it's the same. So it doesn't keep events. So that is the exponential distribution. Okay. So I hope you like it. What do you mean meaningful property? Precious,
Ma,
what do you mean by meaningful
the
property?
assignment zero was a question.
Uh-huh.
At what property is this?
Oh. Eh, eh, eh. Hmm. Okay, I think let's end on exponential today. So we'll have gamma and beta the other time.
Tomorrow?
Yes, tomorrow.
Okay, thank you.
All right.